Okay, well, this is the first seminar for this semester. As I've just indicated, A Young and I started this during the pandemic as a good forum, but the main purpose of it is to have a particular focus, and that's on research that actually deals with accounting and how you handle accounting and how you use the accounting, how you extract from the accounting, how you might get better accounting. We have a conviction that this is really a core part of our mission. In accounting research, there's many things to do, and there's much good work on institutions, on regulation, and of course on auditing and management accounting and so on. It's a big tent. You can do a lot of things, but we feel that this is, we're accounting professors, and dealing with accounting is a primary part of our mission. So the idea is to bring focus to that. I guess, is this the third year we've been doing it, A Young? It's lovely to see so many faces, at least shoulders and faces, of people from around the world joining in this, and I think it has actually been very helpful to me, to all the audience, and of course to the presenters. So welcome again, and hope we have a very good semester. Basically, we're going to meet here every Thursday. Typically, it's 11 a.m. Eastern time. We're a little early today to accommodate but have a good semester. Let's do it. Thanks, Ian.
Thank you, Stephen. And then now our moderator, Totomi, is going to start today's event.
Okay, good morning, good afternoon, or good evening, everyone. So it's actually 11 p.m. here in Japan. But it's my pleasure to be a moderator of the Accounting Design Project workshop today. Thank you, Stephen and Yoon, for inviting me to be a part of this opportunity. So we are happy to have Bin Ka from National University of Singapore as of today's presenter. Title of the paper is Measuring Farm Quality Using Machine Learning. Before moving to his presentation, let me give you some reminders during the presentation. Please mute yourself unless you make comments. However, I encourage you to share your video for active participation. If you have any questions or comments, please use the raise hand function on the Zoom or leave the messages at chat box. Then Bin or I will let you speak. So now let's move on to the presentation. So Bin, are you ready? So the floor is yours.
Okay, thank you so much. Well, first of all, I would like to say Happy Chinese New Year to everybody. Because in China, we are still having the Chinese New Year celebration. I just hear the fireworks outside of my window because right now I'm taking my sabbatical leave in China. So getting together with my parents and etc. So pretty exciting time for me. And also I really appreciate Aya and Stephen for giving me the first slot, because we just finished the first draft of our paper, even though it took us kind of more than 2 years to get together the whole analysis and also the idea. So we cannot kind of wait to share with everybody this new research paper. And also I really appreciate if you have any comments, because we're still revising and how to position our paper in the literature. So let me share the screen with you guys first. And also feel free to stop me if you have any questions. I don't need to kind of to warm up, because the topic we are discussing today is relatively familiar to many of you. And also machine learning is a relatively kind of a popular area. So many of you must be familiar with that. So I don't need a lot of introductions. My two fantastic co-authors, Changyi Chen, a PhD student in his final year in NUS, and also Qi Zhao, who was a visiting PhD student from Southern China University of Technology. She is not an accountant, but she wants to become an accounting professor. So she's from decision science. the main machine learning person behind this particular paper. Okay, both of them are in today's Zoom meeting. So if you have any difficult questions, I'm sure they can help me out as well. Actually, like before I get into the paper, because I started machine learning stuff through like collaboration with people in other disciplines around, I would say 10 years ago. So the first float of my expansion of my horizon over the past 10 years was the JAR paper regarding fraud detection using machine learning. So that was my first accounting paper. But before that, actually, I had some machine learning papers with people from computer science, but they're published not in accounting domain. They are published in AI domain. So many of you probably don't read those papers, which is kind of interesting kind of situation we're facing today, because machine learning becomes so popular over the past decade. And now I have to read so many papers from so many different disciplines. Quite often, topics like today could be done by people from computer science, but they take very different approaches. So over the years, I have been thinking about how to think about machine learning in accounting. So this is one of the papers we are pursuing. Another direction we are pursuing actually is working with companies, especially companies in China, to use machine learning to deal with accounting issues within organizations. So this is kind of one of my key future direction endeavors in the next few years. So you are going to see some papers coming from me, who does financial accounting research, but I'm doing quite a bit of managerial accounting research now. So I'm switching to a kind of a neighboring discipline, which is very interesting. But I feel like we could marriage the two fields much strongly. This, I think, is like Sudip, I know Sudip is in the audience today as well. It's promotion in Temple over the past few years as well. So I hope I have a chance to present my managerial accounting papers using machine learning in the future with you guys. So the key question in this paper is very simple. We want to use machine learning to construct a better measure of firm quality than what's available. So this is like the basic idea. Now, if we can do so, then we have a couple of implications. Now, what we do is, of course, we have a lot of different implications. In this particular paper, we just look at the value investing perspective. First is, if our measure is better, does this mean it can better explain contemporaneous stock prices? The third question is this possible for us to make some money? Which means using the measure, which is based on public available information, accounting data, which will allow you to make up a normal return using the state-of-the-art asset pricing model. So this is kind of the empirical question we call, because if you believe the market is efficient, then probably you should not make any money. So it's more, we cannot leave it as empirical. So this is kind of the nutshell of the paper. The motivation, probably I don't need to get into too much, because most of you should be familiar with why fundamental analysis is interesting and why we want to look at, think about the role of accounting in that particular area. So like here I quote one interesting paper by Charles Lee, which was a keynote speech he made in Australia, if I remember correctly. And he was talking about value investing. What does this mean? And two key things. One is you want to find good companies. Second is you buy them at a reasonable price. Okay. So the key is quality. So this is the key focus of this particular study. How can you find high quality companies? If you can do so, then value investing or fundamental analysis becomes something very interesting to think about. This is like why we're spending so much time in the accounting domain thinking about those questions. Okay, Ollie, you have a comment.
Yeah, just one question about these two slides, Ben. So why, when the goal then becomes to predict stock returns, why do you first need machine learning to derive a measure of quality? Why not just predict stock returns right away?
Good question. Actually, we actually carefully thought about that. Actually, we also have done some empirical analysis and also conceptual thinking regarding this particular issue, which is a very interesting because I know many machine learning papers, they just go straight to stock return prediction. However, like this motivation slide, like the second bullet point, which is maybe useful for you to think about, stock price return prediction is only one possible use of fundamental analysis, in my view. So that's why I have a second bullet. We say reliable measure of firm quality is equally important to many other stakeholders. So in my economic version of the paper, I talk about a different, like for example, governance activists, employees, customers, for example, right? When you're dealing with durable goods, you want to buy stuff from durable companies who will be there in the future, right? So quality could be clearly potentially relevant to those stakeholders as well. So in that sense, stock return is not the only thing we care. So that will be my first response. Now, the second response, even if let's say your goal is to predict the future return, actually, I have done some analysis, which I don't share in the paper right now. Actually, we have two different approaches to this end goal, which is stock return prediction, right? You either take the quality plus reasonable price approach, which we call fundamental analysis, or you just go straight from the raw data, accounting data to return prediction. Now, the question is, which one is better? Theoretically, I don't think there's a clear answer. So I talked to people in computer science as well, because some of my courses are computer scientists. There's no clear answer. However, we did some empirical analysis in this particular paper, but I don't show you guys because we were thinking about drafting another different paper for that particular idea, which is even if we want to predict the future return, this indirect approach through fundamental analysis could be better than predicting stock return directly. And actually, we have some results which I don't show you here. We do show in our context, our approach can make more money than predicting stock return directly using the same input variables, which is kind of interesting. So we're still kind of thinking about how to think about from a theoretical perspective why this is happening, right? And so on.
Yeah, that's very interesting, and I mean, especially regarding your first point. I mean, always the question is then, okay, why not have then separate machine learning algorithms for each individual task for each stakeholder? For example, with your fraud detection paper, there would be another variable, right? So then you could always do it directly. So I'm wondering a bit about that one. But your second point, I think, is very helpful here, and also, if you could really explain how that is happening. I think that this was also an issue we kind of ran into with our paper. So if you would have something in there, I would be extremely interested in hearing about it.
I see. Yeah. So luckily, we did think about this issue, and we have done some analysis already. But I was debating with my co-authors because if we add so much information into one paper, that could be overwhelming to the reader. So that's why we kind of package the current results as one paper. And your question, actually, we were thinking about as a separate paper to show. Yeah.
I think I just have a minor kind of comment related to your second bullet point. When I read the paper, you seem to kind of assume that high quality is the same set of the criteria across different stakeholders. But we also know that sometimes different stakeholders of the same company have different conflicts of interest, right? So like right now, when we look at tech firm laying off large number of employees, they're doing so actually good for equity holders. So their stock price actually increases when they announce massive layoff. But I think for employees' perspective, maybe they are not high quality firm. It doesn't really kind of like preserve their career. So I think here just that when the paper talks about using the same machine learning model and then can extrapolate this outcome variable like firm quality for other stakeholders, maybe need to lay out that you are assuming different stakeholders actually appreciate the same set of the quality criteria. Yeah.
That's a fair point. I agree. Different stakeholders may have different objectives. But in our view, the quality measure using let's say the equity perspective could be still a useful starting point, even if you're not an equity investor, right? Because if you're thinking about like a forward-looking decision making, you want to look for a company who is strong from a financial perspective. So in that sense, I think it's still a useful starting point. But I agree, strong company does not mean pay employees well, right? You need a bargaining process as well. So in that sense, it's kind of you're not seeing one-to-one connection mapping, but I think it's still a useful starting point for people. Yeah. It's harder for me to see the chat box. So Tomomi, if you see.
Okay, yeah, so I read up the comment. Yeah, so would managerial quality be common to all stakeholders? So would managerial quality be common to all stakeholders? The question may be similar to Ayun's.
Yeah,
somewhat related. Yeah.
Yeah. So Deepata, you asked this question, right? So yeah, so I agree they're not identical, but still, my point is it's a still useful starting point for the conversation, right? All right, so now, because this is a machine learning paper, so we want to talk about how we do fundamental analysis and how we are going to do differently in the machine age. So clearly, in the past, as humans, we make all sorts of decisions, including investor decision, so quality judgment, etc. So quite often we use heuristics, okay, using simple metrics and also just using judgment based on your like rule of thumb, etc. Right? So like for example, this is like from one of the I think Charles Lee's papers before, if I remember correctly. So he was referring to Benjamin Graham's stock screening formula many years ago, right? And those similar things have been used by traders in the market. So basically, those are kind of we call heuristic decision making because you use very simple rules, right? Use simple cutoffs, and then we don't quite justify. Calibrate why we use those cutoffs. It's just a bit based on our hunches and experiences from the past. So those are the things. And in the accounting, we also, when we do research, we also do something kind of similar. So when you go back to the fundamental analysis literature in accounting, as well as finance, right? We have identified a lot of accounting signals based on accounting numbers. Which are trying to capture firm quality. But typically we use, I call simple heuristics again, okay? Versus machine learning, which is something we're going to introduce in this particular paper. So this is a huge difference. And we have seen many recent examples in different settings where machines indeed can do better than humans in information processing and information conversion. And this is kind of one of those papers, in my view, trying to see how we can develop better signals, which is relevant to us in different situations. So what is firm quality? In order to do the rigorous machine learning analysis, we have to define firm quality first. Now, this goes back to the previous contribution in the accounting literature, like for example, the residual income valuation model, which is very popular. So I just put it over here. So basically, we define firm value as a function of two components. One is capital in place. Second is the present value of the future residual income. So Charles Lee calls the capital in place part of the valuation as the cheapness measure, and the present value of residual income as a measure of the firm quality. So that's his notion of firm quality one of his previous papers before. So we are borrowing his notion in this particular paper when we define firm quality. So now, because the present value of residual income is an unscaled version, so following prior research, we scale this measure by the book value of equity so that it can be compared across time for the same firm and also across different firms in the cross-section. So as a result of that, we define firm quality as follows, which is a scaled version of the present value of residual income. So clearly, this is based on the expectation now for the future, right? So the future is the Q, the true quality, we call the ground truth in the machine learning domain. So firm quality in our definition is a forward-looking concept, which means you have to predict, which is exactly machine learning is designed to do. So that's why we feel machine learning could be a useful setting for us to look at this particular measurement issue in our particular setting. Okay, I see another comment. Let's see. So Sudipta, do you want to clarify? You say firm quality the same as firm value.
Well, it seems to me that your residual income model is a measure of firm value, right? So
yeah, so this is derived from the equity perspective. Yes.
Label. And the other comment I made was about heuristics. The Altman model uses cutoffs, but is based on a statistical model, multiple discriminant analysis. So, I mean, you can have cutoffs from a rigorous model, statistical model too. So it doesn't have to be sort of just gut calls. You can use statistical analysis. And we use Altman's model all over the literature.
Well, you're right. So the issue is what kind of model you're using. You're right. If you use a very sophisticated statistical model, then that's essentially machine learning already, right? Yeah. So when we say like intuitive rule, like a rule of thumb, for example, you use anything above like a 10% you view is good. Those kind of things. Those we call heuristic decision making, right? And quite often those cutoffs are not optimized using the machine learning jargon, right? So machine learning or statistical analysis, what we do is we optimize the rule based on our testing. We call back testing, right? And then we apply to the future. Yes.
And Bin, there are two questions from the participants. From my understanding, these are related to the construct of firm quality. So one is from Dahan and the other is from Walid. So may I read or could you ask to speak?
You can read. Actually, it'll be great if people can just jump in to ask me the question.
Yeah, I'm happy to jump in.
Much easier for me. Yeah.
I didn't want to speak out of turn. So Ben, what I got confused on is this notion of firm quality. So we keep talking about firm quality, which is a fairly nebulous concept and means a lot of different things to different people. I was waiting for you to define firm quality, not having read the paper. And so here's the first time where you're defining firm quality.
This is my definition. You can see it now, right?
Which is fine. So this is only a comment to say that I think given the nebulous definitions that firm quality can take on, it might be less confusing to the reader if you just say that you're looking to maximize residual income, say. So I think you have a very specific measure in mind for your construct. And so the question is, why not just get right to the measure and skip the construct?
Okay. So because the reason we call quality is that's exactly the term people have used in the fundamental analysis literature, right? For example, the Charles Lee paper in 2013, that's exactly what he uses when he was referring to quality.
Well, so I teach FSA and I use Stephen's textbook. And so I'm trying to think, it's been a while since I've read it verbatim, but I mean, when he talks about firm quality in his textbook, I think there are some ways from an FSA perspective, but we talked about accounting quality, we talked about earnings quality. So there are different, ways in which we can even cut on quality from an FSA perspective. And so I'm not sure which one you're after. And so this is the confusion is,
Okay,
are you
okay,
after
I
accounting
see,
quality?
I see.
Are you after earnings quality? Are you after earnings persistence? Some other notion of quality, maybe it's conservatism, I don't know. But the only issue is it leaves the reader guessing until you've defined it, because again, it can mean many things to many people.
Yeah. So okay, I see. Yeah. So we did kind of define firm quality in the paper very, very carefully. So this is the exact definition you see. So this is what we mean.
Okay.
So is that better now?
Well, no, it's helpful, but all I'm saying is from kind of an expositional perspective, I think it would be less confusing to the reader if you just kind of came out front and said, here's what we're after. Here's the function that we're looking to maximize, perhaps, or whatever the case may be. It's just the issue is I'm not sure what angle you were after. So I was giving you a couple of slides before I jumped in because I'm hoping you would define it.
I see.
And so you did here.
I see.
But again, it's which cut of quality are you after? And as other questions said, to whom, right? Different elements of quality might matter differently to different stakeholders. And so, for example, when you're looking at green investing, right? This framework might not necessarily apply to green investing. Right?
Why it does not apply?
Well, so others might be more concerned with environmental impact, right? So RI might be important to a certain, maximizing residual income could be important to a certain class of investors. It might be a second order consideration to another class of investors who are more concerned about where the funds are going, if they're funneling green projects, for example.
But in the end, so it really depends on, so you're right, going back, let's say, who are you talking for, right? Are you saying this for the green activists? They may not care about equity value, then you're right.
They may care less as the first order concern, that's all. And so that's why it goes back to defining it clearly up front and then making sure which stakeholder you're most interested in. Yeah, so small.
Okay. Yeah. Thank you. Yeah. Stephen?
Just looking at your formula here to find quality, it seems it's just very explicit. It's a firm which has high expected ROE, as you call it, and low risk, low R. Okay, that's what it says. Yeah. And indeed, it's just a firm with a high price to book ratio. So that's explicitly what you're doing. So put another label on it. I don't think is confusing. I was looking for firms with high ROE and a low risk, a low R. That's a bit interesting because that's a high price to book ratio, whereas Benjamin Graham wanted to buy low price book ratios. They were the quality ones that of course, I guess, maybe on the cheapness side of things, but the value investors, those value investors buy low price book ratios. So there's a certain inconsistencies here.
Well, I mean, it has two components. You're right. So because we're talking about quality, and also when you talk about market to book ratio, then you're talking about the market price, right? So in our quality measure, we are not referring to the current market price. So the market price, you are referring to the cheapness, as we laid out over here, right? Over here. So basically, you define quality, which is independent of today's price. And then if the quality is already reflected in today's price, then it may not be cheaper anymore, right? Because the market book ratio could be already pretty high.
Yes,
that's right. That's exactly what
you're looking for firms where the price to book is should be high, but it's actually low. That's the cheapness aspect. I think I understand.
Yes.
But in terms of defining what you mean by quality, it's there in the formula. It's expected ROE relative to the discount rate, the risk.
Yeah.
Which is what we focus on in financial statement analysis.
That's right. Yes. Steve?
Just a very quick comment. What's the difference between this and just growth? And then how do you sort from this growth that you could think of as quote unquote fundamentals versus growth that comes from the accounting? It's just a comment.
Oh, I mean, here we just look at the whole thing, right? We're not trying to like decompose this whole like we call quality into individual pieces. So
I
we
guess
just
all I'm-
say you have,
I guess all I'm saying is you could have growth for two reasons, right? You could have sort of unbiased accounting and then high expected earnings growth because the company is expected to make products that customers are going to want to buy and pay a premium for. And there's going to be growth in revenues and margins because of that. Or you could have growth because the company does things that are risky that don't go on the balance sheet, which in turn leads to high expected earnings growth. And some of that might be picked up in a higher discount rate, but that's not obvious. That always happens. And so I guess I'm just wondering how you sort those two things out, because both of them can lead to a high price to book ratio.
So now, of course, so here we are just taking accounting at the face value, and then you're saying, I think something a little bit kind of probably beyond what we can handle over here. So essentially, what we are thinking, we are assuming is eventually everything will get into the accounting numbers, right?
Yeah, that's not the issue, right? The issue is that book is understated today. And so what that means is that you're going to have expected earnings growth that comes from that. And that firm's going to appear to be high quality, but, and we could have a long conversation about this, but it's not obvious that that quality is attributable to the fundamentals. It may just be the way the accounting's being done. And so one of the things I'm thinking is that I haven't read the paper. So if this doesn't make sense, then just move on. But I expect there's a number of features you're looking at that you're trying to do to predict quality, basically. And it might be interesting to include in those features some measures of basically the degree of conservatism in the accounting, and then show that those features are less important in terms of determining quality vis-a-vis or predicting quality vis-a-vis sort of the fundamental features you look at, because that might allow you to be able to say you're sort of picking up the fundamentals and not just differences in the accounting.
So maybe let's see. So maybe let me jump ahead of time. So maybe later I will define.
It's just a comment, Ben. You don't need to answer it right now. It's just something to think about.
Maybe later when I come back to my measure of I call the ground truth, which is the true firm quality, which is defined based on the future information. So maybe you can come back to this issue again, because you were talking about what are the inputs we should use to predict the quality, right? So we do kind of have multiple dimensions. Maybe when you come to that, maybe you can talk about that. Yeah.
Just to expand on Steve's point here, I mean, it's deflated in book value, so it depends on how book value is measured. So if a firm doesn't have assets on the balance sheet, say Coca-Cola doesn't have its brand, it's going to have a high book rate of return. So you're calling that, because they don't put assets on the balance sheet, you're calling that a high quality company. Okay, so that sort of raises issues. It has a very high book rate of return, 20-25%, because it hasn't got assets on the balance sheet. So that, in your view of a quality company, it's firms that don't have assets on the balance sheet.
You're right. So then essentially your book value today is understated because many of the intangibles are not recorded on the balance sheet, right? Then the income would be reflected in the future. So that would lead to higher inflation of your residual income in the short run.
Yeah. I mean, think about it this way, Ben. The cost or expense today for investments that will generate earnings in the future, return sales in the future. So those costs won't be matched with those future sales. And so you're going to have quote unquote overstated future earnings and ROEs is a way to think about it.
So, but then if we kind of add them together into the future, going into the future, if I remember correctly, Stephen, I remember I read one of your earlier papers, or maybe a book, I can't remember where. You mentioned, like, for example, you had one claim: if a company manipulates its accounting numbers, actually the valuation would not be affected. Is this true?
Well, as long as it's detected, yeah. If you have lower book value now, or higher book value now, you're just going to have lower ROE in the future, and so the formula protects you, okay? As long as you're aware of that income shifting, okay?
That's right. That's
Your
right.
income shifting doesn't affect the valuation under the formula, although in practice it can deceive.
Yeah, yeah. So I needed to think about, it's like Steve's comment regarding accounting conservatism, etc. How, because right now we take the accounting system as given. You're right. So we have not thought about very carefully on this one. As a result, our ground truth could be measured with some noise, which is possible. Yeah. So I needed to think about if you have any suggestions, how can we improve we call the true form quality based on the future information. If you can have any suggestion, let me know. Please let me know. Yeah, Ollie.
Yeah, just building on this, I mean, another thing you might want to look into is Steve's recent papers on conservatism as an asset pricing factor, right? Because I mean, in some sense, this measure is picking up that very much, right? So I feel like essentially what you're doing here is you have the typical fundamental valuation formula, but you get rid of the capital part, right? So usually when we think about the residual income model, we have book value of equity plus the future discounted residual income. You just get rid of the book value of equity here and indeed scale by it. But usually what preserves value is that you have both in the same formula. So now you basically take one number, this is the future residual income, and you have it as the denominator, and you scale by book value instead, which then exacerbates that problem of your measure essentially becoming a conservatism measure. Because if you do that, well, for example, you have R&D, then your book value of equity falls and your future residual income increases. So your measure very strongly co-varies with that. And then, of course, you have the situation that you have, as Stephen has shown with some co-authors, that this is strongly positively correlated with conservatism. And if conservatism is a priced asset factor, then your stock return results would be expected from that prior literature, right? So, I mean, just in terms of kind of framing it into that literature, that would be useful if you could maybe talk a bit how your measure relates to that.
Okay, yeah. I need to think about this because I'm not kind of paying close attention to the new development in this area. So I needed to think about this. Yeah, Aya? Yeah.
Just want to remind you that you have like a 20+ minutes left.
Yes.
If you don't mind, can we jump to the machine learning and tell us that how does that solve the big questions that we all have in mind? Thank you.
Okay. The machine learning part is the easier part in this paper, in my view, or for any applied machine learning papers in accounting, in my view. So this is like, so when I was thinking about machine learning models, it has three crucial components: data, model, performance evaluation criteria. So my fraud detection paper, we cover all three dimensions very carefully. So we apply the same principle to the fundamental analysis paper here. So basically, I think the key innovation, in my view, for accounting researchers is not the model part, it's the data part. So if you think about, let's say, we define the ground truth, which is the true form quality. Whatever machine learning model you use, you could use deep learning, and we use XGBoost in this paper, or random forest, etc. Right? You could have many different machine learning models you could consider. But for us, accountant, our key contribution actually is not the modeling part, it's the data part, in my view. So we kind of promote this idea in this paper as well. So the key challenge we're thinking about is how can we use current data to measure the unobservable ground truth Q. So which is the function we're having over here. Of course, the function will be learned through machine learning. Let's say you use a linear regression, which is the simple way, right? We're using machine learning, which is non-linear. But I think regardless the form, the specification you use, the key is the X. How would you pick the X? So this is the part we are going to think about in this particular paper. So based on my prior experience in the fraud detection setting, I always believe, after discussing with different experts in computer science, theory motivated model input is always crucial to machine learning building. So we looked through the previous fundamental analysis literature and trying to look for insight. And we did find an interesting paper by Asnis et al. 2019, published in RAS. So they develop a theoretical framework of film quality, which is consistent with the definition we're using in the previous slides, which can be expressed as a function of four additive components, which are profitability, growth, safety, and the payout. Payout is embedded in the growth as well. So this is the formula I just can cut and paste from their paper, which they derived from their assumptions regarding how different components are evolving over time. So if you have not read the paper carefully, I urge you to take a look at their paper. So under their assumptions, then the value to book scaled version would be expressed as a function of those. And we rely on their theoretical framework to develop the proxies we're using in this particular paper. Ollie?
Sorry, just a quick side comment. So, I mean, it's not entirely consistent, right? Because when you look at this, they have value scaled by book, and what you're using is just discounted residual income scaled by book, right? So you avoid kind of the book value term of the residual income formula here. Just something to think about, right? Because I mean, if you were really only talking about value, which you don't, right? You kind of talk about this future income stream, then would match. But I feel like right now there's a bit of a divergence here, no?
Well, because remember, the scale is the book value at time t, which is today, right? Okay. We use the same measure. So essentially, remember, if you go back to the formula, right? So the value essentially today's book value plus the future residual income discounted to present value. So if you scale by the book value today, so the first component becomes 1, is a constant. So that's essentially the same as you just focus on the second component in this formula, right? Yeah. It doesn't matter, it's just a constant. So in that sense, I think we're okay. That's exactly what you're seeing over here, right? So essentially they are talking about the second component of the residual income valuation model. Yeah. So now so Asnis et al. 2019, so they kind of build their proxies for the film quality measure using this framework. So for example, the profitability, they can identify different measures. Now this part is a little bit ad hoc in my view in their paper. They look at it like they call gross profits over assets, ROE, ROA, cash flow over assets, etc. They're all related to profitability. But what principle did they use to pick those particular components? It's kind of empirical in my view. Okay, there's no strong theory behind, but their theoretical framework on the previous slide is derived from their basic assumptions in the valuation. Okay. So this is a key thing we're talking over here. So they look at the profitability, growth, safety, payout. So 4 dimensions. And for each dimension, they identify proxies to capture what they're looking for. And they're using essentially the z-score, the normalized measures of each component before they add them up. Okay. So essentially, and then they define the ultimate goal, which is the quality measure in their paper, which is essentially it's the sum of those 4 components, because their theoretical model says it's linear, right? So they also do the linear over here as well. Yeah, and then in our paper we call Asnis Q-score, okay, to represent this particular measure in their paper. And for our paper, our goal is we want to use machine learning. So our starting point is Asnis Q-score. Now, Asnis does not use machine learning. They only did the Q-score based on what we call heuristics. Now, this is the heuristic version of quality. So because they do not use machine learning, so we want to use machine learning. So we need to have a benchmark. So our benchmark in this paper first is we just use the Q-score, which is derived by them, and then use the Q-score as the only data input for the machine learning. Now, the second part is, well, why do you use Q-score? Your Q-score is done in a heuristic way. So our first question is, can we just use their 19 standardized individual components, which are used to compute their 4 dimensions and ultimately the Q-score as inputs for machine learning. So this is the first part. And then later we're going to add additional data. I will come back to that. Okay. And then what happened? So essentially now for machine learning, we look at 2 different kinds of models. One is the linear regression we are familiar with. The second is we use a more advanced machine learning model we call XGBoost, which is one of the most powerful machine learning models in the machine learning field. Okay. We just picked this one based on our initial investigation. We did not try any others. Okay. So the key is we want to think about humans tend to be linear, but machines can be nonlinear and interaction so on. So that's why we want to pick XGBoost as a good example of machine learning. And we use more detailed data, which are the 19 proxies identified by Asnes et al. But they use the Q-score, right? So we use the Q as a benchmark in our paper and see what happens. Performance evaluation metrics. So because our dependent variable is a continuous variable, so now typically we use mean square error, right? But mean square error could be subject to kind of the influence of outliers. So in this paper, we focus on the MAE, the mean absolute error, which is less subject to outliers influence, even though our conclusions are all identical if we use MSE. Actually, the results are actually even better if we use MSE. We do the typical machine learning stuff like cross-validation to optimize the hyperparameters, etc., and so on. So I'm going to skip for this audience. So we do the standard versions over here. And then the timeline, which is very similar to what you have seen in the previous papers, like for example, like the Ho et al. 2012 and the Lee Mohanram 2014, they also use similar form because different companies have different fiscal year end. So we have to pick a particular time in a calendar time. So we pick June year T as our decision-making time. And then we use the past data available to us, which means if the company's fiscal year is before March 31st year T, then by June of the same year, their financial reports are available to us for use. So that's the common assumption we use in accounting literature. So then we use the past data to build a machine learning model to measure our firm quality. Is a forward-looking concept as we have defined before. This is what we're going to do over here. Okay, we have comments here. So the first one is Walid. You say Q-score was constructed without referring to the ground truth. As such, using Q-score to construct your baseline benchmark seems odd. A bit of a straw man, perhaps. It seems. Let's see. Oh, my screen too small. Hold on a second. It seems linear regression LI19 should be your benchmark model. Well, this is a difference in view, I believe, because remember, Asnes, they come up with a Q measure, but they do not use machine learning. So we do not have a comparison. So that's why we want to use the Q-score as our starting point. And then, oh, oops, sorry. So then we want to introduce disaggregation of the data. Because remember, so Q-score is a measure people use to predict the future, right? So Asnes et al.'s argument is high Q means high quality. But they use just simple heuristic, just the Q, right? And we are just linked to the future ground truth, which is the realization of the quality. So we want to kind of link the Q with the future to see how strong they are. Now that's the goal. So in that sense, I feel like this is the right benchmark we should use. Second one.
So Ben, so now you have only 10 minutes left. And so if you still have some important point or
Yeah,
result,
maybe because
maybe
the
comments,
comments just too many for me to read. So maybe I just go slow, and if you have any, the best is for people to ask me right away. So it's much easier for me to respond to. Yeah. Okay, let me come to. And then another issue when we are dealing with accounting numbers is missing values. So I'm pretty sure all of us know we have a lot of missing values in compute step, right? So when you use a lot of accounting variables, then if you require non-missing, for example, you are going to face a big problem, a huge sample selection problem. So in order to deal with that issue, what we did, which is very similar to what people did before, we try to fill in the missing values to the extent possible based on our judgment and expert's view, right? Based on accounting notions. We did something similar. So we give you a lot of details in terms of how we deal with those issues. And then later, I will also show you, actually, the way we deal with missing values has no impact on our inference because our most advanced machine learning model, XGBoost, can handle missing values directly. You do not have to make any assumptions by yourself. So I will show you in a minute. Okay. So how should we measure the ground truth, which is based on the present value of residual income going into infinity, right? So we just follow prior research. We do 1 year expansion as our main analysis, but also we do 2 years and 3 year expansion. So the 1 year expansion, then the expected ROE becomes the future realized ROE. So the ground truth becomes the Q is the realized future ROE, which we don't know today at time t, but it will be realized in the future to measure the present value of the residual income. But a 2 year expansion, you have something similar, and a 3 year expansion and so on, right? And then anything beyond your terminal year, you make an assumption. In our case, we assume the growth will be 0. So this is what people typically use in the literature. Okay. So using the 1 year expansion, we use, to the extent missing value is not severe. So we start from around 1976. Our actual data, we started from 1973, but because we need 3 years of data for training. So actually our test period would be 1976 to 2018, okay? First, as we can see, the first message we want to show you is disaggregated fundamental signals are more useful to measure firm quality than the Q-score, which is the aggregate measure based on human heuristics. So whether you use the linear model or use the XGBoost, you get a pretty good improvement in performance using the MAE, for example, in our particular paper. So this is the first message. Second message is machine learning using advanced model is better than linear regression. Okay. So if you hold the input constant using the Q or the 19 individual proxies, you get a substantial improvement in performance as well, based on MAE. Okay, so that's the second message. If you combine the two together, so then if you use disaggregated signals and advanced machine learning model, then your model performance would be, like in our case, the reduction in the MAE would be around like 27%, which is a substantial improvement in prediction. Yeah. So this is the first message we want to kind of show you, which means machine learning based on theory motivated measures disaggregated rather than the Q-score would be much more useful. So this is the first one. Our missing value treatment doesn't matter. So we have two machine learning models. One is XGBoost 19. The second is XGBoost 19M. M means we leave the missing value there, do not do anything, and let the machine figure out how to deal with the missing value. and our performance essentially is very similar. So that means how you treat the missing values for advanced machine learning models like XGBoost, it does not matter that much, which is kind of pretty useful to us for accountants because we always have to worry about those things, right? When you're thinking about prediction, but actually for our case, it doesn't matter at all. Over time stability of performance, we give you a figure over here. The performance of XGBoost relative to the benchmark model actually is very stable over time. It's always the best model from 1976 to 2018, which is suggests the machine learning model is pretty good, even though it sees fluctuation over time, but it's always the best model you could imagine. 2-year, 3-year expansion, similar conclusions. Now, the only difference compared with the 1-year expansion is because 2-year or 3-year expansion, you need the forecasting of more years of data. Then the measurement error, the forecast error would getting bigger as expected. But the packing order we did before is still the same. Now, this is kind of which means our model is very stable. Now, on the base of that, remember, we started with a theory-driven model input selection, which is the Asnis et al.'s model, right? But an interesting question we have to think about is the theory complete? Are we exhausted? Now, fortunately for machine learning, we can play with those numbers, which means the financial statements, we have a lot of additional variables, raw data we have never used, right? So in this particular paper, we look at the 3 different steps. The first step is the 19 proxies used by Asnis et al. 2019. They are not the fundamental raw accounting data either. They are already aggregated. So we decompose into more refined variables available from the financial statements, which would lead to 63 financial data items. Step 2, we pull out some additional fundamental analysis papers in the most recent literature. So we picked 2 papers over here, the Lee Mohanram paper and also the Bartram and the Greenblatt paper. As a result of that, we lead to 87 financial data items, which means 63 plus some extra ones, total is 87. Step 3, data mining. You put in all the available financial data items from Compustat. So we identified a total of 318 financial variables you could get. Okay. Try the machine learning model, what happens?
So sorry to interrupt, but you have 2 minutes left. So you may want to wrap up. Yeah.
Yeah, I'm almost done. Don't worry. I think I have enough time. Yeah. So what happens? So this is what I call inductive analysis, because we really don't have any theory to guide us. So we kind of try kind of more empirical, and hopefully if we find something very, very substantial, then we have to look at the numbers to understand what's going on, right? So this is the inductive analysis, and then it could inform us about theory building, for example, right? Unfortunately, in this particular setting, additional variables beyond Asnis et al. Theory-driven inputs, they make a little difference. The total best from the 318 variables, relative 19, the improvement in performance is only 2.6%. So it's pretty small compared to 27% improvement we showed before, right? So what's the takeaway from here? So the implication we are trying to argue is theory matters in model input selection, which is important for applied machine learning researchers like us, which means the combination of machine learning and the data input selection based on theory, we still carries its day in our setting. Okay, we have our measure, then we have some, okay, now if you can do well, then what does this mean? So one application we're trying to show over here is we show the value investing setting. First is, if this measure is useful, maybe investors may be already using that already based on their own decision making, right? So then can we better explain current stock prices? The answer is yes. So the column 1, we use the true firm quality based on the perfect foresight, which is the future realization. versus column 2, our measure versus column 3, SNIS Q-score. Now, in this case, now we can use the Q-score because we don't need to use machine learning anymore. Why? Because SNIS Q-score is already a measure of quality. So which is
Sorry to
different from-
interrupt again, but Ayun raises her hand.
Sorry, I think I just want to remind you, I think our time is up.
Ah,
Yeah.
okay.
Yes, time's up. Yeah, yeah. So this is the one. So which means our measure can better explain the price today. The second question is, can we make money from the prediction? And here, what we did is we use the value investing approach. So the time horizon, you have it over here. And what we find is, indeed, we can make more money than SNIS Q-score using the most advanced like a asset pricing model in the finance literature. And it's very stable over time. It's not just it's only valid in older years. It's also true in the most recent time period. And also more data, the better for the portfolio return. No, actually it's not. So our 19 proxy based on SNIS et al. Is still the best measure you can use to make money, which is kind of interesting as well, which is consistent with the prediction performance results we have. So overall, I think we find something interesting, and it's applied machine learning application to accounting, and we feel how accounting information can be used for machine learning prediction in our context, which is firm quality. It's kind of, we feel like a theory is still quite important. So this goes back to like Stephen's book, for example, and also all these papers, they use a different theory, right? Which is based on Nissim and Penman's hierarchical approach. So which is something we have not done yet, which is potentially interesting is, what if we compare with this approach? Which one is better? Now that's an interesting question we are thinking about, and I'm not sure, should we incorporate this into the paper today or we live into the future? Okay, I will stop over here. Thank you so much.
Thank you, Ben.
Thank you very much. You prepare a slide to announce the next
Oh,
presentation.
yes. Sorry, I forgot about this. So our next ADP event announcement, which is very important, right? So our next speaker is Vivian Fan from Minnesota, and she's going to talk about something crazy, I know. Very creepy, right? Cryptocurrencies, yeah. Okay, sounds a very interesting topic. Okay,
Thank
I'll
you.
be staying here. If you, unfortunately, I did not have time